All right, awesome. So, we are halfway done, right? End of week 5, so that's pretty cool. Uh, and we're ready to go on to like the even more awesome part of the course. So hopefully you turned in PA2, PA3. And you only have 2 PAs left, yeah, but they'll be goodies, so you definitely won't be bored with them. Well, last class for a while. You never know. I might pop up strange places. Yeah, this has been a really fun class, actually. Even though I've like never met most of you in person, or in some cases even seen you. This has been a really fun class for me, like from the beginning of a fall term, and in some cases going back to last year with 250, 270. So it's been a good one for me to teach. So let's see. Um, yeah, definitely. Yeah, totally. That was cool. All right, so I will try to get PA3 graded this weekend. I have a really busy weekend coming up, so I'll see what I can do. But I got some tools set up to pull down your code and so on and so forth. So I'll start going through those this afternoon and get grades posted as soon as I can. Um, oh, cool, awesome. Hey, my pizza throwing has gotten better too. That was like one of my first attempts, and I've actually gotten it to where I can like get some air on it. So um, it's pretty fun, and I'm making pizza way more often than I should. Oh, cool. Well, you could go back there. You could show them how to toss it. Yeah, I think you got to make a mess, and you got to have disposable dough. All right, so let's talk about PA4, and there's a lot of stuff going on in PA4, and I'll show you like a quick demo of what it could look like, and then we'll start talking about what we need to actually make this code. And we're gonna have to go deeper into um, how we deal with painting on widgets, how we actually use pixels to create images and so on. So let me pull up the assignment. So got posted to Canvas yesterday. So this is the most awesome game ever created, right? So this is called Dots. Um, and it might have some other names also, but when I was a kid, I learned this as just Dots. And it's pretty straightforward. So it's usually played with 2 people, and you start off with a grid of dots. So we'll just do a 5 by 5 board. And my friend Larry, we went to school together. He and I used to play this during class. We'd pretend that we were sharing a textbook, but we'd really be, playing a game of dots inside one of the pages. So it is a stick game, right? So you have a grid of dots, and so this is Larry and Nick playing. So you take turns drawing lines, horizontal or vertical. So I might draw a line here, and then Larry would go here, and I would go here, and Larry would go here, and I'd go here, and Larry would go here. And the goal is to complete boxes. Okay, so you take turns drawing lines, but if you're able to draw a line that completes a box, two things happen. One, you get your initial in that box, and two, you get to go again. So I might go here, and then Larry could go here and complete a box, and he'd get to go again, so he'd go here and complete a box, and then maybe he'd go there, and maybe I'd just start a new area over here. And so you go on like this. And when all the boxes have been drawn, whoever's got the most initials wins the game. All right, so that's the basic setup. And your goal is to implement this in Java using Swing and make it a graphical game where two people basically share the mouse, and by coming in and clicking, right, the program should draw the lines for you, and it should notice when a box has been completed, and when that happens it should put the player's initial in there and give you another turn. So it keeps track of whose turn it is, and goes on like that. So the boxes are all one by one. So if you're playing the game like this, and then I draw a line right here, I still have not completed a box. But the next person who moves, if they draw a box right here, let's say it's Larry, he gets credit for both those boxes, and he still gets to go again. But you only get one extra turn. Yeah, he is. But if you complete, you know, more than one box, you get each of those boxes. But yeah, then you get to go once. All right, so that's the basic setup. And you keep going until the board is filled up, and it'll say, you know, who won. And you can keep a score tally on the side, so show how many boxes each person has as the game is playing out. You want to detect illegal moves. If you click outside, you shouldn't just like randomly draw a line. If you click on a line that's already been drawn, just tell the person, you know, that line has already been taken, and it's still that same person's turn. They still get to go, because you don't want to be able to skip a turn by doing that, because that's a big cheat opportunity. And that's basically it. So, so let me show you a possible implementation of this. So I'm calling this dots. So I run that, and I get this game popping up. Right now, if I click in here, nothing happens because the game hasn't started yet. I got some debug messages coming out here on the side. If I click, you know, before I've started the game, nothing happens. If I start the game before I put in initials or names for players, then it's not going to work. So we'll keep picking on Larry. So now I can say start, and so current player is Nick, and here's our score. And when you click that, it goes to current player is Larry, and there's Nick, and we'll let Larry win a few. So Larry got the box, and he gets to go again, and now it's Nick, and now it's right. So it just goes like this. And now I'm going to grab a whole bunch of boxes. Right, and it goes on like that. And you can give up at any point. You can hit a restart button and go back to the beginning, and it clears out the playing field and puts your scores back to 0. Were they not centered? Oh yeah, they aren't centered. Yeah. All right. So yes, you have a lot of creative freedom on this one. I will specify the functional behavior that I want out of this, but how you set it up is up to you. The look and feel is completely your choice. How are you going to indicate whose turn it is up to you. What are these going to look like? All of that, right? So that's totally your choice. If you want to, you know, embellish these dots somehow, you can do that. If you want to center the letters in the boxes. And yeah, you can totally use colors and cursive dots. All right, and if you play through to the end, and this is hard, it's an 8x8 grid of boxes, so it would take a while to get to the end. But when you get to the end, you should announce who won, right? And then you can use the restart button to start a new game. You can make it variable. I would like a default of 8x8, but you can put options in there for a different board size. And it's nice to be able to make a smaller board also, just to sort of play through to the end and make sure that everything's working at the end game. And I can't change the player's name once the game is started, which is nice. Otherwise, you could just swap with like somebody else. So yeah, you could ask who goes first and what size board you want and so on. Definitely with flowers and everything. All right, so let's take a look at the written out specs. So implementing a version of this using Java Swing and your object-oriented design and coding expertise, which everybody has developed very nicely at this point. I recommend Eclipse because there's a lot of classes in here. There's a lot of graphical stuff we're going to have to do. And you know, Eclipse imports things for you and so on and so forth. But, you know, your choice. Alright, so allows two people to play dots on a shared computer. This is not networked, okay? PA5 will make this networked, but for PA4, it's one computer, one game, and you just sort of hand the mouse back and forth. So you take turns playing on this one game. Alright, so two people can play dots on a shared computer, take turns, use the mouse to select lines, program draws the lines, complete boxes, adds initials, tracks the score, whose turn it is, and so on. Alright, so here's a brief synopsis of the game that we just went through, but that's in there as a reminder. Alright, bonus points. This is a group project if you like. You can work in up to groups of 3 people. Alright, you can work alone if you prefer, but you can have a group of 2 people or 3 people. Your choice. And whoever you decide to work with and however you decide to split this up, I strongly recommend each person do the entire project. Okay, this is a really, really kind of important learning exercise as far as object-oriented design and getting deeper into classes and so on and so forth. So, you know, normally on a project you might break things up, like say one person's going to work on the graphics, and another person's going to work on the basic gameplay, and another person's going to work on updating the state of the game, right? And that would make sense, but for this, I want everybody to be able to do the entire project from start to finish, okay? Because it's a learning exercise, right? But how you split it up, that's totally up to you. And then you can continue with this group for PA5 if you want. So it makes sense to spend some time thinking about how you're going to use the group aspect to your advantage. And, you know, since it's a group project, this is where you get to share code with 1 or 2 other people. And you get to bounce ideas off 1 or 2 other people and get help with debugging and so on and so forth. So you know, figure out how that's going to work best for you if you want to do group work. A lot of cat conversation going on, yeah. I was down a cat YouTube rabbit hole last night. I grew up with cats and I haven't had a cat in a while, so that will probably change somewhere down the road. Cats are awesome, but so are dogs. Alright, so as far as submission, make sure your Git repos are consistent. Okay, so when I'm grading, I'm going to download, you know, the repos, and I usually go through them in alphabetical order, section by section in Canvas. So if you're working with somebody else and I download their repo before yours, you really want their repo to have the same code that you have, right? To have the version of the code that your group wants graded. So either make sure the repos are absolutely consistent, or whoever, you know, is not wanting their code to be, you know, graded, just remove that code from your repo, or call it something other than what it's supposed to be called, and so on. All right. Also, really, really important, in the beginning of every .java file, somewhere right up at the top, I need to see the full names of everybody who's in your group. Okay, because I'm going to use that when I'm done grading a submission to decide who gets the credit for it. So make sure, you know, if you're working with 2 other people, all 3 of your names are in the top of every .java file. All right. So the requirements, it should begin with a 9 by 9 grid of dots. So that represents an 8 by 8 box playing field. I would make the box 50 by 50 pixels. Okay, so that it fits easily on the screen that I'll be using. But make these variables, right? So set up some symbols. You can put them in a static field if you want, but make it easy so that if you decide you wanted to do a 4 by 4 game, you don't have to go through and find everywhere that you hardwired an 8 or a 7 or a 9. It's just a variable somewhere, like, you know, game width, game height, box width, box height. Right, so avoid the magic numbers, make them variables. Allows 2 players to enter their names in text fields and then hit a start button to begin. Track whose turn it is. Display some way of letting the people playing know whose turn it is. So highlight or print it out or something like that. If you click inside the grid area, draw the closest line. If the line's already drawn, report that and let the user go again. If a box or more than one box has been completed by the latest click, you should add the user's initials to those boxes and then keep it that player's turn for the next click. Keep track of the score, update it each time that a box gets completed, and display that somewhere on the game field. And then when all boxes are done, tell the people that the game is over and report who won. And there's a restart button you can use to reset and go back to the beginning. If you want to print debug information in your console window, that's fine, but everything that you need to know about playing the game should appear on this playing area, right? So if there's some important message like, you know, the game is over, you want to display it here. Don't just system out print line it and leave it on here, because I'm not going to look at this while I'm playing the game, right? So this is going to be, you know, high quality graphics, right? So I'm going to max out our GPUs. All right, so everybody understand the basic setup? All right, so your main class should be named dots, which means your main file is going to be dots.java. How you break this into classes, totally up to you. So, but I definitely need the main class to be dots.java. So you want to put all of your .java files into a subdirectory named dots. Yeah, 4K dots, definitely. So subdirectory named dots and upload it through the standard repo we've been using this course. Use the default package again. Test your code outside of Eclipse if you develop in Eclipse. Make sure that you're not doing anything strange with, you know, libraries or packages that you imported into Eclipse that I might not have access to. So it should just run, you know, from the command line. So for me, I've got my Java files. If I compile them, I get my class files, and I can just say Java dots, and that brings this up. So I'm going to run this from my own, you know, laptop. That's where I usually do my testing. But if you want to see if this works on the Linux server, right, you can go into the Linux server with SSH, but put this dash uppercase X on it, And that creates kind of like a tunnel that we can use to send X Windows commands back from the server to, in this case, my laptop. So if I run an X command like xeyes, right, I get a GUI, right, running on a remote machine, but interacting with my mouse and, you know, displaying on my display. And so in my descriptively named AAA directory, I can run dots from here. And this will take a minute to start, and it's a pretty slow way to do this, but it will work, or at least it did work yesterday. Unless it doesn't like playing with the screen sharing. Awkward silence. Huh, that's interesting. I'll have to play with this. Anyway, hopefully you've got your own Linux set up, because developing this on the server, once you do get it to work, is still really painfully slow. So, you know, you should have a Linux set up somewhere. If not, you can VirtualBox this and run it inside Windows or whatever you're on. OS X, it should work, but your mileage may vary. And, you know, if you're working in a group, you can use each other's equipment and so on. Okay, that's not bringing it up for me. I don't know why, but that's okay. Cool. Yeah, Kause is fun. Oh, totally, totally. Hey, I bet you could do that. So this can get a little wonky, but remember from C, you can say system to run a system command. Well, you can do something similar from Java. It's a little more involved, but same idea. So, but you could probably port Kause to Java, or find someone who's done that. Then you could have the Kause class. All right, so so make a subdirectory named dots, put your .java files in there, upload that to your repo. Grading is, you know, you can read this, but basically you're going to know if your game works or not, right? But make sure, you know, you check these things, right? Obviously, it's got to be able to compile. It should draw some dots, show initial scores, let you put in your names, use the initials from those names when marking boxes, respond to mouse clicks, draw lines between dots based on where you click, handle illegal moves like trying to take a line that's already drawn, add initials, keep track of whose turn it is, show the score, and have a restart button. So do those things, you got 100. All right, so let me run quickly through a bit of this setup suggestions. This is pretty long, and it may not make a lot of sense right now. So let me just do a few highlights on this, and ask you to read this and ask questions next week about it, because I want to get into some of the programming aspects of this today. But you know, again, suggestions that I'm offering. You don't have to do things like this. But if you're not sure how to proceed, I think this is possibly a useful way to break this problem down. The most important thing is this is different from the other programs we've been writing, right? The programs that we've written so far, including PA2, are very sort of, you know, step-by-step oriented. Open a file, read it in, build a tree, read the first node, print that out, get an answer from the user, move to the left or the right, and so on, right? It's very step by step by step. That does not work in this assignment, okay? This is moving into this totally different approach to programming, which is event-driven programming. And so this is all about, you know, tracking the state of your program and then responding to events based on your state and the event to update the state. And I'll give you an example, right? When you're playing dots, right, if you click, somewhere in the middle, what you'd like to do is draw a line between two dots, and if that completes a box, you'd like to add an initial in the middle of the box and then update a score, right? When you write your mouse code, none of that stuff is going to happen in your mouse handling code, right? We cannot write code which says when you click here, let's draw a line and then check if the box is finished, and if it is, draw an initial in the middle. Okay, this is very significant. So when we click a mouse, we'll run into a section of code, right? We'll have a mouse listener that will be able to do some things, but that mouse listener cannot draw. We can't put any code in there that says, draw a line on my playing field, or draw the letter N at this location. When we want to do that kind of drawing, it happens from a totally different class and a totally different method. And it always happens in the same place. So as you're playing the game, what you're really doing when you get a mouse click is you're updating state information. You're making changes in memory to say, hey, this person now owns this box. And hey, this line has been drawn. And that line has not been drawn. And here's what each person's score is. You're updating that information, and then something else is reading that information and using it to draw the playing field, and to draw the initials and the boxes and so on and so forth. But they're separate tasks. So here's your memory, right? And it knows about lines and boxes and scores and whose turn it is and so on. Here's your J frame, which has things drawn on it and so on. And here's the user who has a mouse and so on. And basically your mouse events are going to go into, swing, right? Something's going to pick those up, and it's going to run pieces of your code, and your code can look at the current game state and make some decisions and update the game state. But that's all that your code does. It gets these events and it tinkers with memory. But somewhere else, there's some other code, right? We can just think of this as swing, which will interact with this memory and update what's displayed. Okay, but our mouse clicks are down here. They're this code over here, and this code does not have access to what's drawn on here. It does have access to the memory, and the thing that has access to what's drawn on here also has access to the memory. So if I want something to be drawn here, basically I have to update something in the memory so that this thing, which is reading memory and drawing my playing field, will draw what I want it to draw. Okay, so that's a very different approach to programming. It's going to feel awkward perhaps at first that, if I want to draw a line, I can't just say draw a line. I have to say blah 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 blah, in such a way that this thing will say, oh, okay, I should draw a line. All right, so we're going to have to shift into that mindset. So this is what I mean by event-driven code. Mostly nothing is happening until an event occurs, like a mouse click. And you can do what you like, but you need to do something and get back. So that's the other thing. We don't get to loop in here, right? If you put a while loop in here, things will break, right? So think of this as an interrupt handler. If you've done 270, someone clicks a mouse, come in, do something, get out, right? We're never going to sit here and loop and wait until an event occurs. We're not going to sit here and loop until the game is over or until a mouse is clicked or something like that. We're just going to hang out in the background. When a mouse clicks, we'll run some code, we'll exit, we'll wait for the next event. Okay, so that's the event-driven part. It's also helpful to remember that you don't get to paint things whenever you like. Okay, so we're going to talk about the paint method shortly. Um, Definitely ask questions along the way, right? It's another 2-week assignment, and this one is longer than PA2 for sure, right? PA2 sorry, PA3 was super challenging in other ways, but this one is a much larger project, right? This will be a lot of code when you're done. So ask questions, right? And the way I suggested breaking it up, right? Make yourself a class named box, which describes a single box, right? Just an area with 4 lines on it. And what do you need to know about a box? You need to know which lines are drawn. You need to know if somebody owns that box, right? And if you make a box like that, your board is just an array of boxes, right? So make an 8x8 array of box objects, and that's your board, that's your playing field. And so each box can have booleans for the 4 sides of it. It can have some sort of way of representing who owns that box. Cool, yeah, kind of like tic-tac-toe. That would be fun in Python. All right. Definitely more than ever before, modularize, right? Make lots of methods. It's really easy to start getting lost in variables, and I think some people probably already experienced this in PA3, where you can have, lots of variables that kind of mean the same thing, but, there's a copy of it in this class, and a copy in that class, and a copy in main, and we can avoid that by using methods, right? So if we want to know what the current score is, we could store that in an integer somewhere. We could store it in the board class, right? And try to get it from there. We could store it in, multiple places, and then you have to keep it consistent. But you could make a method called current score. And if it's a method in the board class, all it has to do is go through all 64 boxes and count how many are owned by each person. Right? So what's the advantage of this? The advantage is, if I have a method for telling me what the current score is, I never have to worry about updating the score. Now, when does the score change? The score changes when somebody completes a box. The score changes when somebody hits the reset button to begin, right? If you had an undo, the score would change when you did an undo. And if you're keeping track of the score in an integer, then you have to update that integer in each of those cases. And those things might be happening in totally different places in code and so on and so forth. If my current score is a method, it doesn't matter at all how the board got changed. Anytime I call current score, it's going to count up what the current score is based on the information in this memory view of the game. And it's always going to give me the correct score. So be thinking about that, right? How can we take information and encapsulate it in code, right? Have a method which will calculate this information for us, rather than trying to keep track of it in variables, right? Where we might have to do a lot of extra housekeeping to keep those things up to date, and if we have multiple copies, to keep them consistent. So make a method for initializing the game board. You're going to have to do that in the beginning, but now your reset button, all it has to do is call that initialize method. And if you write that well, that's it. You're done. It's one line of code to do your reset button. Make a method to update the score, to check whether the game is over, to check whether a move is legal, to update the game board based on a move, right? Put each of these in its own method. And this will help, right? If it's something that kind of stands by itself, right, within reason, think about putting it into a method. And this will feel awkward for a while, right? When somebody marks a box, we'd like to increase their score by 1, right? Well, that's just, player 2 score plus plus, right? But if you have a method in your board class which says, add new box, and you can tell it if it's adding it to player 1 or player 2. Well, in that method, you can do whatever you need to do. You can bump up their tally. You can update the display. If you're showing who's ahead, right, you can check that and change which player you're highlighting to show that they're ahead now, and so on and so forth. So this is a lot of design, right? And this is another reason for the group aspect. You should kick these things around, spend some time thinking about this, and then have some conversations and say, how do we want to handle this or that? All right, so you're gonna have a mouse listener for your game area that's gonna need to decide where a player clicked. And we'll talk about that next week. I'll give you some ideas and a handout to help with figuring out what mouse clicks correspond to. But ultimately, when you click somewhere, you need to know what line is the person trying to draw, and that's just arithmetic gymnastics. And be methodical, right? Once you get things set up and you figure out, what the basic parts and pieces are, this is actually a really fun assignment, right? It's easy to break down into different parts, and it's pretty fun as the game starts to develop, to be able to play different parts of it and see it get further and so on. And then once it's done, it's like really cool to be able to play and show off to your friends and so on and so forth. Use good variable names, right? Score of player 1 instead of S1 or A or something like that, because there's a lot of parts and pieces in here, right? And if you can avoid getting confused on those parts and pieces, right, that's going to help. All right, let's talk about drawing in Java, and this will make more sense after that. But let's get into some code. But I want to at least get through this. One example of this, because like I say, this is a different style of coding. So let's make a project. So I'm going to call this painter. And let's make a new J-frame. So the usual drill, we'll do a new other, we'll go to all of that stuff, we'll make a J-frame. And I'm just going to call it main. I often named my variables after Pink Floyd lyrics when I was in school, so whatever is going to help them make sense to you, right, is a good choice. All right, so here's our board area, right? And I'm gonna do an absolute layout, right? So I'm not requiring you to make the board resizable and so on. So 50 by 50 box, and if it's 8 by 8, that's 400 by 400 plus some extra space for buttons and labels. So this easily fits on a display. Wow, cool. Did you get a comment on the cost node? So let's just imagine, we've got some buttons here and some labels and so on and so forth. So somewhere in the middle here is going to be the actual playing area. So let me make this whole thing a little bit bigger. And the drawing area, I'm going to say let's make a J panel. Okay, so I'm going to pick a J panel, and I'm going to drop it right here, and it starts off pretty small. So I'm going to make it big. So this would be where I intend to actually play the game of dots. Okay, and I'm going to come over here to advanced properties. I'm just going to add a border so that we can see more easily where this J panel is. So I'll just add a bevel border. And so now if I run this, here's what my game looks like, right? So I got buttons and scores and all that kind of stuff. And here's where the dots action happens. All right. So let's talk about how we draw on here. So there's a class called graphics, right? Which is part of the abstract windowing toolkit. And it has all these cool methods for, like, you know, clearing a rectangle, drawing an arc, drawing a 3D rectangle, drawing a line, drawing an image. This is the package that will do all of our visual display elements for us. And I encourage you to look at this and mess around with it and see what's in here, right? We can do rounded rectangles with rounded corners, and we can draw strings, and so on and so forth. All right. So the trick is that to call any of these things, like to draw a circle, which is actually a draw oval method, right? We pass x, y coordinates for the center. We pass a width and a height. That's pretty straightforward. But where do we get our graphics object from so that we can say, you know, graphics object dot draw oval? So we need an object of class graphics. And we could just, you know, create a new graphics, but it's not going to be connected to our display. All right. So this is also super critical. Everything I'm saying today, I know I'm saying it's super critical, but it really is, right? Because this is totally mysterious otherwise. So the main action in the graphics class is painting. So when you draw things, when you draw rectangles and text and so on, nothing actually shows up on your screen until you call a paint method. The funny thing is, we're not allowed to call paint. So let's look at a J panel. So this inherits a paint method, and paint is used to draw components, right? But to call paint, we have to pass it a graphics object. Applications should not invoke paint directly. All right, so you can try, but it won't actually paint. So what we do is we call repaint. All right, so here's the weird little setup that we're living with for the rest of the course. Here's our J panel. And swing has a paint method, which will go ahead and it will draw stuff on the panel. And here's our code. And we can do some stuff to you know, say what we want to have happen here, but ultimately we have to call paint. Well, we call repaint. And repaint does not actually cause painting to happen. What repaint does is it tells swing, hey, when you get a chance, call paint for me. And somewhere after I call repaint, swing will call paint, and swing will update the display here. All right, so we have to go at it through this indirect approach. All right, I have used up too much of our time here. Let me do a really quick run through of this. So let's make a class, and I'm going to call this class my panel. So I'm going to write my own version of the paint method. So I'm going to do public void paint graphics G. And it's going to draw an oval. And I want to use this panel instead of the J panel that I have in my window. So what I'm going to do is I'm going to create this class my panel where I'm going to say this extends a J panel. And it's going to complain about J panel. It's going to say, I don't know what this is. Maybe you want to import it though. So I'll just click that. It'll do my import for me. And so now I've got a J panel like thing that has a paint method that's going to draw an oval in the middle of the panel. So if I come back here and I look at my source code, right, this is where I create that J panel with the bevel on it, right? What I'd really like to do is make this a my panel. So all I've changed in my code is, you know, I create my J frame, I put a button down there, I create a J panel like thing, but it's actually a my panel. And my panel is an extension of a J panel. It's exactly like a J panel, except the paint method is different. The paint method says, let's draw an oval. And so if I run this, there's what I get. So I get a box with an oval drawn in the middle. Or a parabola. Now if I come in here, let's do a fill oval. Now let's make it a little smaller. So I'll go ahead and run that. And so there's my oval. Or we could do a triangle. Right? My main program never says draw an oval. My main program simply constructs a my panel, adds it to the content pane. But when Swing is trying to display this J-frame, it knows that there's a panel here, and it will call that object's paint method, and that object's paint method says fill an oval in the middle. Yes, conic sections. Your math teachers are all dancing with joy right now. All right, so that's a way to do drawing from Java. So we'll build a lot on that beginning Monday. But that's a basic setup. So I would say, you know, your first task is spend some time thinking about how you want to structure this. Figure out if you want to work in a group, right, and get the group logistics pinned down, and then start thinking about the structure for this. And if you do this kind of thing, right, you can do a draw a line, that will draw a line. You can draw a filled oval that's really, really small, and that'll make a dot. And so you can start doing some drawing of the game playing area. All right, so we'll build on this Monday. Have a great weekend, and I will see you next time.